Okay, so still graphing quadratics, only these are going to have imaginary numbers for x-intercepts. So, finding x-intercepts, always remember change the y to 0 and solve. Since this equation has two x's, we will have to factor or use the quadratic formula. Because of that negative in front of the x squared, I'm not going to try to factor that, so I will use the quadratic formula on this one. So, here we go. X equals negative b. Now b is a negative 1, so that's going to make it positive 1. Plus or minus the square root of b squared. So negative 1 times negative 1 will be positive 1. Minus 4 times a, which again, there's a negative 1. Times c, which is again a negative 1. There's a lot of 1s here. All divided by 2 times a, so negative 2. Alrighty, so pretending we have no idea what this type of number will be, we're going to type this into our calculator and see what's inside of our square root. We'll have 1 plus or minus the square root, and then divide by negative 2. So, in our calculators, 1 minus 4 times negative 1 times negative 1 ends up being negative 3. So right then I know this is going to be a no x-intercepts problem because that will give me an imaginary solution. So write it showing I have an imaginary number. X equals 1 plus or minus I square root of 3 divided by negative 2. And the meaning of that is that we have no x-intercepts on our graph. Okay, so how does that affect our ability to find the line of symmetries? Normally we would add up our x-intercepts and divide them by 2, but we just said there aren't any. Well, what happens if we do it anyway? We would have 1 plus I square root of 3 over negative 2 plus 1 minus I square root of 3 over negative 2. And we would divide that all by 2. Now this decidedly is very messy to look at. But if we focus on these pieces right here, you will hopefully notice that they're identical. Only one is plus and the other is minus. And so they actually cancel each other out. So what we're left with is really a lot more simple. Negative 1/2 plus another negative 1/2 divided by 2. They're negative 1/2 because the 2's were negative. The negative can go with either the 1 or the 2. I just put it out in front of the fraction. Okay, so adding two negative 1/2 together, we'll get negative 1 divided by 2. So it's 1/2. X equals negative 1/2 is the equation of the line of symmetry. It's our first characteristic of our graph. So let's try to draw that on the graph here. Negative 1/2 would be right here. Okay, so let's get something else to go with it. Let's get a vertex. Once we've done our line of symmetry, the vertex is the same as it was even when the x-intercept existed. We'll plug in our line of symmetry. Remember, you can use negative 0.5 instead of negative 1/2 in your calculator. We'll grab our graphing calculator and we'll put trace. Okay, so you grab your calculator, and in y equals, you put the equation, which was negative x squared minus x minus 1. And then we press graph, and then we'll do trace negative 0.5, and you get negative 0.75. So on my graph, I'll have a dot at just a little bit down, about right there, negative 0.75. And then I have to find my y-intercept. Find my y-intercept by making my x be 0. So 0, comma, something. And I get that something by, once again, going back to my graphing calculator and doing trace 0. I'll get negative 1. So head back up to the graph. Place a dot at 0, negative 1. Let's see. I can enlarge that a little bit. So we're going to place a dot at 0, negative 1, which is right here. And we can get part of the parabola drawn. So how are we going to get that other part? We have our vertex. We have a y-intercept. Excuse me, I wrote x. We have a y-intercept. And that's it, because remember we had no x-intercepts. So how do we get that extra point? Well, we need to reflect our y-intercept dot to the other side of the line of symmetry. Our y-intercept was half a space away from the line of symmetry, so it has a mirror image half a space away to the left. So now we can complete the parabola. Okay, let's shrink that down there so we can see the entire picture from beginning to end. Because it had two x's, we solved for x-intercepts with the quadratic formula, but we found out they were imaginary. We were still able to add them up and divide by 2 because the imaginary parts canceled out. So our method for finding the line of symmetry doesn't have to change. Then we plugged that in for the x to find our vertex using our graphing calculator to get that. And then lastly, we plugged in 0 for x for our y-intercept to find it. When we made our graph, since we did not have any x-intercepts, we had to use a reflection point. We had to use a reflection point in order to achieve the graph. Okay, so let's try one more example. Let's see if we can shrink this down some so we can see it. Okay. And let me get rid of that line I just drew. Or maybe not. Okay, well, we'll just live with that. Okay, this time we're going to make the y be 0. And because we only have one x, we will solve by undoing. So the first thing we'll do will be subtract 5. And then divide by 1/2, not negative 1/2, 1/2. Remember, when you're dividing by a fraction, you actually get a bigger number, so that's negative 10 equals x plus 2 squared. And then we square root. So positive or negative, the square root of negative 10 equals x plus 2. And lastly, subtract 2. So x equals negative 2 plus or minus, because of the negative 10 in the square root, we have imaginary number, I square root of 10. Which for the graph means there are no x-intercepts. But we can still add up what we have and divide it by 2 to find the equation of the line of symmetry. So x equals negative 2 plus I square root of 10 plus negative 2 minus I square root of 10, all divided by 2. Same as our previous example with the quadratic formula. The imaginary pieces, one is positive, one is negative, they'll cancel each other out. And so we have negative 2 plus negative 2, so we have negative 4 divided by 2, so we have negative 2. So x equals negative 2 is our equation of our line of symmetry. So right here will be the middle of our parabola. Then we'll bring that for the x to find the vertex. And lastly, we will plug in 0 to get our y-intercept. Both of these are done in the graphing calculator. So I'm going to grab my trusty Casio and enter the equation. Remember, either if your calculator doesn't have a fraction key, make sure you put 1 divided by 2 in parentheses. Draw the graph, and you can tell when you're drawing the graph that it really doesn't have any x-intercepts, so you're doing it well. We want to put in x equals negative 2 for the vertex, so we'll do trace negative 2. Enter. We'll get 5. And while we're at it, we'll do trace 0, and we'll get 7. So we have 2 points to put on our graph at last. Negative 2, positive 5 up here, and 0, 7 right there. So we had our vertex, and we had a y-intercept, which allows us to make the right side of our parabola. And same as on the previous example, in order to draw the left side, we need to use the reflection. We need to remember that the line of symmetry is in fact the middle, and so a point that appears on the right will have a mirror image on the left, and then we can connect it through. So we have to use the reflection to have enough points to graph, when we do not have x-intercepts. In other graphs, the reflection of the y-intercept is optional, but not if we only have 2 points. Okay, so there's one example of how you can solve by undoing, have no x-intercepts, and still complete the problem. And the previous example was using the quadratic formula and having imaginary numbers and still completing the problem. So, hopefully we have a full toolbox now for graphing quadratics.